Yeah, we figured it out, honestly. Well, I figured it out. I just didn't show you guys. I probably should have showed you guys. Would have probably been a good learning experience for you guys. I did start over, which is the thing. I probably should have showed you guys because I started over. It would have been better for you guys to understand. Maybe I might do that since I'm not that deep in it and I understand what I gotta do now. And it's just a better layout. I could do that for you guys. I don't know if you guys are worth the time though. That's the thing. If you guys are worth the time, then I might do it. If you guys want to see me do it, then I might do it. Actually, it don't hurt to do it. Fuck it. Let's learn. Let's learn.
So, starting over. Starting over. So we got the main function, right? Do this first. This is gonna be the main function. Okay. We want to add a library called stdio.h first, just for things like print, things probably like exit. That's just a standard library you just automatically need at the start of your things. So the first thing we need to do is called create the server. We need to create the server first. Okay. So what do you need to create a server? What's the first things you need to create a server? So first, first we want to have an IP and port for the server. Okay, we want to have an IP and port for the server. Once we have the IP and port, we want to create the socket for the server. So let's create socket. If you don't know what a socket is, it just allows you to receive information, send out information, accept clients, connect servers, and things like that. It's just a network object, okay? So you'll just need it for the server. So once we create the socket, we'll want to store some variables in the internet protocol family. Okay, so let's say store store information in the internet protocol family. And then once we have that, we can basically get on with the socket. We can bend to the bend to the bend to the host bend to the host IP and port. Then we can listen for the listen for certain connections on the listen for certain connections. Not really gonna listen for anything. And then we're gonna ask yourself, where do we accept the socket? I'm gonna accept it in here just because this is the main function and this is where we're gonna handle important information. Okay, accept the client's connection though. It's gonna be the client's connection. So
So to do this right here, to do all of this, uh, to do all of this, we need to create a function. We're gonna call this socket. Nah, I don't want to call it socket. We just call it sock creation. We do this, we do that. Oh,
here, okay. So first thing, right? And honestly, the first thing we can have it outside of the server, since like it doesn't have. I mean, not outside of the server. It just can be global variables. Okay, just on the main line. Every time we call this variable, it'd be the same no matter where it is. Okay, we don't have to call it in a function. So we say server. We say server IP is equal to, and this is just your local host. You could just allow your local host to be the server IP, and then define. Define is like it's a shortcut. It allows you to server port. Allows you to call server port. It's like a variable, okay, basically, but you'll just use this. You'll just call this, okay? You can just call it, and it'll be 8-8. I'm sorry for the yawning. I'm pretty tired. What time is it? It's 11:26. So honestly, as of day one, we're just gonna create the socket for the server, and then we're gonna expand. Okay, so we're gonna expand. So if you guys want to see day two, like, comment, okay? Definitely drop a comment which I want to see next after these videos are over. Okay, so let's get into it. Let's create. We define that. What's the next step? Next step is to create the socket. So let's create the socket. So we just call it sock is equal to socket. And we can say AF in it. Sock underscore string. Right? All capitals. These are macros. All capitals. And yeah, this is not gonna work if I don't do those. And now we want to add our what's it called? Since we need a socket, we need to add a library to use the socket. So let's add sys socket dash 8 dot h. It's a header. I believe that's what that means. Okay, so basically that's it. We created the socket. Now we need to store our information in a network family. So in a network family for our socket. Okay, we're not gonna. If we go here though, this site. If you, I will put this site in a link in the description. Okay, for you guys. But we go here. We can use I believe is net init for the internet protocol family, right? And we'll be using the socket. We'll be using this right here, this structure. Okay, so let me struct sock address underscore n, and we just call it server. That's all you gotta do. Call it server. Okay, so include is net init, right? Net init dash n, net init dash n dot h. Right? Is that right? Okay, the first one we need is the send family. So sa fam such as IPv4 or Unix domain socket. Okay, so this allows us to store IPv4, IPv6, or a domain socket, a Unix domain socket, but we're not going to do that. We're just going to use a regular structure for this, okay? So let's do server, turn the caps off. So call the structure name, right? Server, and then let's do, we go back here, right? What's the one? Send family. So send family. What is a send family? That's what we have to ask ourselves. Send family. Send family and C. Since we're coding in C, what is a send family and C? An address family for a transport address. This member should always be set to AF init. Okay, so it should always be set to AF init. So send underscore family. That's our answer right there. Is equals to AF underscore init. Init, right? It's that simple. Once you understand how to use a socket, you can basically build anything you want because the socket is what creates the server, what creates the client. You need a socket to communicate. Like that's how we talk. We talk with a socket. If we don't have lips, we can't talk. If you don't have a socket, you can't talk. You feel me? If you don't have an address, you can't tell people where to go to. If you don't have a port, people can't knock at your door. And once they open the door, if you don't have a socket, they can't talk to you. If you don't have lips, they can't talk to you. So like think of it like that. Things you need for that, okay? And then the next one is the port. So server send underscore port. And here's the thing with port. So I'm gonna look this up. Send underscore port and see because integers and integers, strings, and domain names they cannot just be strings and integers in network, and they have to be set to a readable binary number for networking. So so the server can read it. So like, it's best to show you guys. Remember, which is used to store. It is a 16-bit undersigned integer, crucial for. Okay, when working, it is essential to handle byte order correctly. Network byte order. Big endian is used for transmission, while host byte order may be different. Low endian. Go to deep on here. Now I said we're gonna go deep, but let's go back. The function hton host to network short and intels network to host short are used to convert between these byte orders. Before assigning a port number and SIM port, hton should be used to ensure it's a network byte order. You see, before assigning a port number to SIM port, which we're doing right now, we're using SIM port. We have to use hton should be used to ensure it's a network byte order. When reading the port number should be used to convert it to a host byte order. When reading the port number from should be used to convert it to a host byte order. See how they're using 880? Crazy, right? Alright, so hton's function, what are we calling this? We're calling it our macro because it looks better. You like the red, right? Rather than 880, you just like the red. Look at it. It just looks better. Okay, it just looks better. Hton's, Hton's is we have to use ARPA init or ARPA dash init library. Okay, so just add that in there so you're not behind. ARPA dash init dash h. Okay, so we're on to the next one. We're not done with we're not done, but now I believe we have to do send underscore address, which is equal to. Now we have to turn this address into a network byte order also. How do we do that? You may ask yourself, how do we do that? How do we turn it into a network byte order? Just go here. You'll start to understand what you need for things like this. You could just okay, we don't need this. It's not telling me nothing. Let me go here. Header, official. What is the definition? So we need to manipulate We need to manipulate our strings. Okay, so we go back to ARPA because ARPA turns our port number into a network by order. It must turn our string into a network by order our our string dotted notation to a network by order. Okay, so function converts a string pointed to CP into in the network standard dot notation to an integer value suitable for the use of internet address. Okay, and a standard dot notation. This is where we have a dot notation, and what to an integer variable suitable for use as an internet address. Network number. This is something you could try right here too. I don't know if this works. Maybe I might try it. Function converts the internet host address specified to internet standard dot notation. It's all about trying things. See, like I don't use this so many times. This is what we'll be using. So if you want to try it on your own, you can use this right now, and I'm not gonna help you. You can just use that. Go ahead and try. To an integer value suitable for use as an internet address. Use as a network number. What is a network number? What the fuck is a network number? What is a network number? See, when you don't know something, you just look it up. So a network number. Converts to an integer value suitable for use as an internet network. Okay. Enter. Hold on. Enter network. Let's see. Oh, I said enter. It's in it. Okay, in it. In it. Network. Let's see. Use. Alright, so play it safe for now. We just do init address to turn it. And then we just want to specify what we have there. Let me actually, we didn't declare this, so go back right now and declare this as a constant variable. And maybe we can have a pointer here, which will, and then we differentiate it, right? Differentiating, we gotta see what that does. Let me see. I don't know how to, I don't even know if that's what the word is. That word gets to me, I'm not gonna lie. This word, I don't fucking know. Uh, see, so it does do that. Let's test it. You don't have to do this, but if you trust me, just follow along. And yeah, keep following along. Alright, so let's add an if statement to check if the socket was created. So if right socket is equal to error no. So go up again. We do include error no dot h. I think I need something else. I need string. Alright, so add include string dot h. If you want, you pause it, slow it down, look at it, but always okay. So I'm gonna do this for you guys. Server IP. Go back and do this if you haven't did it, because this is what you'll need to do for every single line of code if you don't understand it. Server port. And then if you're freshly new, do this. Server IP which is a back. Sorry about that, mic died. Okay, so server, which is a constant character, it will never change, and then we have a pointer that will point to this memory address. Let me call this. Okay, so let me see. I do want to understand a pointer. When calling a pointer without, what the fuck is this word called? D. Okay, times like this is when you just gotta go to ChatGPT for some serious input, man. So when I call a pointer, right, without using the pointer points to the memory address of, what the fuck, of the value stored in it. And when I call a pointer using the pointer, what's what's the difference? Yeah, something like that. What's the difference? Okay, the address of X. Memory location of X versus X storage. Yes, I know that. Alright, fuck it. They want me to. Alright, so print. I'm about to figure out the difference right now myself. Fuck them. Print. We tab. Right, we tab this over because I know this is the pointer. And then we just S underscore IP. Should be good to go. GCC's, we do that. We do TP server 2.c. You guys don't have to do this. You can just watch and see what I'm trying to understand. Directory. What the fuck just happened? What the fuck just happened, bro? This that bullshit, bro. This that bullshit. Start the fuck over again. You guys probably already have it, so just bear with me real quick. You guys were ahead of me, and I had to catch up. So never think you're behind, because even a teacher's behind. Just remember that. Even someone teaching can be behind, and you'll probably know more than them. Even though they're teaching, you'll probably know more than them. So yeah, okay. So we're just gonna print. This is just debugging or error checking, so you don't have to fucking do it later when your code's not actually working. So you want to do it every time after something, after you create something. So print. Let's say fail to create the socket. We do tab it over, we do the decimal first, tab it over, then we do the string. And then we can just say next line. Error no, string, error, error no. Did you mean? No, I didn't mean that. That's because I know why the socket's not working. We have to do this. It's not like, see, I'm so used to fucking Python and shit. Not even used to Python. I was just coding in Python the other day. That's why. And the address has to be constant. Do I not have that? Is that not? So you just gotta go back and look at things. Send the address. Okay, we have send the address, right? And it, why isn't it working? Mm. Too few arguments for the socket creation. There has to be a flag here. Oh, zero. That's high structure. Wait. Brother. So we gotta figure this out. I don't know. I don't think this is gonna work. Yeah. I was trying to say it's an integer, but it's structure, struct. Okay, struct. Hmm. I actually don't know what the issue is, so I'm just thinking. Types from saying this is an unassigned integer. Oh, what the fuck? This should not be the hard part in the server. Like, this should just not be the hard part in the server. That's all it is. That's literally all it is. So that doesn't matter. So, I think because of the function, let me see. Okay, no, it's not. Think about the type when assigned to type struct and address from type. So I'm saying the structure and address sock and so struct and address. Mm. Okay, so it has to be the S. That's where I'm messing up. So send. So your code is wrong too because I never told you to add this. So just add this at the end, and now yeah, we should be smooth. Uh, uh, print. You're gonna do this too because you want to see if it works. Print successful, successful. Next line is test it out, see if it works. If it works, then yeah, move on. I don't know what the fuck is going on. Hmm. Oh, I do know what's going on. First off, creation. Okay, successful. It works. It works. It works. It works. Okay, our socket works. You had to call the function the main function. So to check it, just type socket creation and the function down here, and yeah, it'll work. So now that we've done that, what's the next one? So we created the socket, we checked it, we stored that. Now we have to bin to the server. What does bin into the server mean? Okay, let me break this down for you guys. If socket is equal to error, no, do this. Else, simple, do this. Let me say, error, no, and a string. Or this is a converting error now. Converting error no to a string. Excuse me. So now we need a bin to the server. Now we gotta go to the socket method. Let's look at the bin method. Let's look at the bin method. Let's look at the bin method. Bin. Bin takes the socket, the address of the structure, and then the length. And we can do this all in one try too. So let's test it out. So we do bin function, right? We do sock, which our socket is, and then we have to typecast it. We do struct. It's a struct address. We typecasting it because struct sock address, right? We have sock address, and it's gonna point to server, right? Points to server. And now we need to get the size of the server. So size of server, boom. And then we can just say bin is equal to. And I believe this is returns that. What does it return? Let me see. Return value returns 0 and -1. So if you go here, do bin is negative is equal to -1. Pending to the host failed. Is equal to -1 and error no. I just like to do error no because it literally gives you the error message, which is very cool. So you don't have to fucking guess the error message, you know? It just tells you the error message and then you can just look it up and figure it out. And then we do else. Print. Else print. Binding to the server. Binding to the server. Successful. And next line is. You always want to hit the next line. Just because everything will be on one line if you don't. Okay, server. Server. So now what's the next one? We have to listen for certain connections, right? Okay, listen for certain connections. What does that mean? Okay, let's go back. Listen. Takes a backlog. What is a fucking backlog? A backlog. What is a backlog? Backlog season. Listen get to 0. That was backlog. It's less than 0 function. Okay. Backlog. And see. Number of pin connections that the socket can hold. So the maximum number of pin connections that our socket can hold. I want that to be 3. Must have, yeah, they said backlog is 10. Fucking weirdos. Take that. I don't know if you guys can hear me. This would be tragic if you can't. I've been recording for an hour and 18 minutes. That is what you call grinding, okay? And we don't need to check for listen. Fuck it. So now, what are we doing? We're accepting the connection. We need to accept the connection, right? Okay, so we need to accept the connection. What do we need to do to accept the connection? Of course, we need to use the accept function. But now we have to store all. Okay, another thing. So we have to sock sock. That's your sock right there. So when we call our function for a new socket, like a sock, like a file descriptor, a socket file descriptor, we'll use it. So if I do integer client underscore file descriptor, right, which is the client socket now, and now we just say client underscore fd, which is a pointer. So now every time we call this, so we can, first off, we have to create another structure for this part here. We have to create another structure. So sock address underscore n, and then we can just say client and then close that. But we don't have to specify everything because this is just for the accept method. Okay, so we do this. We have our variable. We store that into the function, and now when we accept the connection, because the accept method, right? We go back. Where does the accept method come in? Right? Where's the accept method at? Where's the accept method? Accept. See? We have the structure. We have to accept. We can't just accept it from this structure up here. We have to create a new structure that stores all the information of the socket. You know? Okay. So now we do client fd is equal to accept, and then we do, hold on, client file descriptor, and then this is client sock, and then we just do this integer client sock. The file descriptor is what we're using for the client socket. Let's just call this client connection. Sounds better, smoother. Okay, so now we have to typecast it again. We go from structure sock address points to client, and then we get the size of client, and then boom, and then we say if client connection is equal to error no. What do we want to do? We want to print the message for error no. Print. Let me just do this. Error no. String error. Error no. String. Tab it over. No. Decimal. Tab it over. String. Next line. Client. Exception. Fail. That's all you need to put. Tab it over though. And then we do else. Print. Client. Client connection. Accepted. Accept the next line. Boom. 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 That's basically the server. Well, it's not the. It is the server. That's the server right there. Okay, we got some issues. A pointer from an integer. Hmm. Okay, we have the right idea. We just have to we just have to fix everything. We have the right idea. We just have to fix everything. It comes with experience. Though. The more you do it, the better you get, and the less errors you'll have. So, assignment to integer from integer makes pointer from integer pointer from integer. Hmm. Hmm. So what's the difference? Like now, because I know this would work. If I call this, differentiating it, storing that into there, let me see. Comparing it from an integer between a pointer into an integer. It's a pointer? It's a pointer? Let's turn that from a pointer. Pointer from integer is still a pointer, same. Okay. Just go deeper, let's just start fucking with things. It's that simple. I don't fucking know what I'm doing, but I know what I'm doing. Like, it gets like that. Look, that was the fix. To non-scalar type requested. Bench sock address. I think I gotta point it to it. Because right now it's not pointing to it, it just looks crazy. So, if you have the same error messages as me, do this. If you don't, and you got some other error messages, shoot, best of luck. You better figure it out or ask in the comments for some help. Please ask for it in the comments for some help. That's the best option, or look it up. Bin is not a function or a function pointer. Mm. Mm. Hold on. Fuck, this is fucking me up, bro. This is fucking me up. I'm just going one by one. One by one. Each error message that pops up at the top, that's what I fix. You know, see? Now, let me show you. So the fixes, let me show you the fix here. This has to be a pointer, so it points to the function. Okay, points to the function. Every time we call this function, it'll go to here. It'll go to anywhere that sock is being called. What's another one that we fixed? This bin right here, because I'm trying to declare bin, which is a function to a function. Like, look, it's not a function or a function pointer. I can't use the bin. I can't just call bin. And that's really it. What else we had? Here, we had to add a pointer. What else? Here, sock had to be, yeah, that was the main problem at the start. The socket had to be a pointer if I wanted to use it to declare it as a parameter. So when I call sock and I place something here, it will point throughout the code each time. Okay, so what's the next print? This print function right here, that's what it says. Print that, boom, 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 boom. What else? Too many arguments for the format. I didn't even add the things that I wanted. Fail, tab it over. What's the first one? Decimal, tab it over, string. Sock has to be a pointer. Sock has to be a pointer. Sock has to be a pointer. So I'm guessing this probably has to be a pointer. Pointer from an integer, but argument. Size of client. Steps pointer from an integer without a cast. Long unsigned integer. These are minor fixes. We just go. Yeah, we just call this a pointer right here. Alright, fix that. Okay, that was not the fix. This probably the fix right there. Yeah, that's the fix. Now we gotta get the size of this so we can use let's get the size. Getting the size of a structure. Let me see. Call it like that, size of. Okay, size T. That's the main thing. Okay, so we just do this here. Go down, go down, go down, go down, go down. What do we call this? Okay, we gotta do it here. Size underscore T, which is, we say client s is equal to size of client. Right. Client underscore s. What happens after that? Pointer from integer without a cast. It wants me to use sock length. That's what it's saying, sock length. Sock length. Okay. Do that there, bow. Boom, 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 boom. There we go. HTTP server 2. I was waiting for a connection. Oh, it failed. It's waiting for a connection, so let's try to connect. NC-4127. Port 880. Connect. Oh man. Oh man. Okay, so got the basic server. Now we can send a message if we want to do that. We can send a message to officialize the server since it's closing and because it doesn't do anything, it just ends. So let's send a message to the client once they connect. Send in a buffer line after the buffer, okay. Excuse me. We need to store a message and a buffer. Okay, so they just stored it in a buffer. Just stored it in a buffer. Let's say this is the simplest one. Welcome to my server. Okay, welcome to my server. And then they get the length of the buffer. So let's get the length of the buffer. So buffer underscore length is equal to string length of buffer. Because we'll need that for our function. Well, yeah, our function, which is send. So let's send. Hold on 1 second. Let's send to the client sock the buffer, and then the buffer size, which is that. Right. Then we could do, what is it, return though, so I don't fuck this up. Yeah, okay, so integer, let's say message is equal to that, and then we can do if mess is equal to error no. See, I love error no. That's like the best thing that came to see, honestly. Fuck, I need to specify each error for. If I could just use one big error that contains every error. Failed to send a message, tab it over. We do the decimal first, tab it over again, we'll do the string again, and then we'll do error no, string error, and then we'll do error no, else, print, message, sent, message, I don't know if it's bad, message, okay, and return 0, we can close client FD here. Alright, close, let me see, close function, let's see, Unix, that's what I need, I need to know what library they uses. No, not the file descriptor. Close the client connection. I guess. What the fuck? Saying too few arguments. Do I give a fuck? Nah, I don't really give a fuck. String error. Do that. Return that. It's probably because we need to use the flag that's trying to specify. Zero. Fuck it. Zero. I don't care. It closes right away. This is that shit I'm talking about. Watch. It's not doing what I wanted to do. It might be because the function is. Oh yeah, this is just that bullshit, bro. I'm back. I don't know what the fuck is going on. This shit making me. Segmentation fuck. Core dumped. Something's going on. Mm. I don't know if you guys see the difference, but I do. And it's all because of belief. So this. Yeah, I mean do that. Okay. Okay, now it's ready. Hmm. Waiting for a host to connect. Welcome to my server. Ah, man. You know, after that long grind of figuring something very stupid out, showing you guys what went on, now it's time to break it down so you guys can understand the code.
Because you see it works. So now that it works, yeah, you believe in me. You believe like, okay, this guy's not bullshitting, and I'm not bullshitting. So let me break it down. So let's say this is sock creation function. Just go over your code, make sure it looks like this if you haven't already. And if you had to figure out these problems yourselves, because if you're copying me and you testing it out, you're gonna think, yo, this guy is sending me down fucking bullshit. But the thing is, you have to just figure out the fucking problem yourself. Or you could wait and then see what the problem is and then just fix it yourself and think, like, okay, this was the problem. Structure to store internet, family information. Right. hmm Do this. Do this. Okay, so if it's sock is equal to 0, which is successful, do that. We're bending to the server here. So you guys should be able to see now what is going on. Bending to the server. I believe I broke the bend function down. This is our file descriptor, a socket. And then we're pointing to the server. But we have to typecast it because bin uses structure sock address and we're using sock address in. So we typecast it. And then we get the size of the server and then we're checking it. If successful, if successful, oh shit, do this, do this, listen, make certain amount of connections. 2 hours long of me recording. Yeah, this is gonna be a crazy video. Client, client variable, variable, sock creation using the variable client fd, which is now our socket for the client. Okay, the issue was I was using a pointer instead of the grabbing the memory address of here and storing that into the function which will be used throughout sock and that function. So now it has the memory address. So when I use client fd, the memory address is sock, right? So think of it. I use memory address right here, right? The n, and then I get the memory address of the variable. Now that variable will be used here, 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 here throughout the function. And then I can just use this variable in here to accept it. Okay, so like that. That's basically what the issue was. What's today? Today's Tuesday. The structure accepting the client connection, checking if it's successful. Do this if successful. Do this buffer for the string, getting the size of the buffer, sending the message in the buffer to the client, checking if it worked. Ah, close the connection and then return successful. It's basically happened throughout the server, man. So if you guys want to see some more, because as you see, there's a lot more to do. There's a lot more to do, and yeah, let me know if you guys want to see some more. Maybe the next thing was probably to handle clients' requests. That would be the next thing. If you guys want to see that, we'll probably do a get request. And yeah, that's really it for the end of this video. Hope you guys liked it. If you did, comment what you liked about it. Anything else, give a like, comment, subscribe. I appreciate you guys, and I'll be dropping another video pretty soon. Enjoy.